I want you to picture a barrel of oil. It's just, sitting there in your basement.
Mhm.
It's heavy, it smells kind of gross, and honestly, unless you have a refinery.
What if a business could just build itself? It sounds like something straight out of science fiction, but it's really not anymore. Today, we're going to trace this incredible story that kicks off with a simple 19th century ledger and ends with AI launching entire companies pretty much all on its own. Welcome to the new autonomous gold rush. So let's just start with the one question that's driving this whole revolution. Could an AI, with basically zero human help, build an entire business from the ground up? It sounds a little out there, right? But as you're about to see, the building blocks, they're already here. Okay, to really get where this is all headed, we've got to look back at how it all started. So let's rewind the clock and meet the very first data prospectors. This timeline really lays out the whole journey for us. I mean, the data business began so simply back in the 1840s, with a few pioneers just figuring out how to sell information. That simple idea grew into the huge, complex data operations we see today. But the next leap? Wow, it's into a future where AI agents are calling the shots. It all kicked off with a really basic problem, trust. As merchants started expanding back in the 19th century, they had no way of knowing if someone on the other side of the country was a good credit risk. Entrepreneurs like this guy, Lewis Tappan, saw that gap and created the first data businesses to collect, analyze, and sell creditworthiness. They were literally selling trust. And that idea grew into giants we know today, like Dun and Bradstreet. All right, let's fast forward to right now. The core idea is still the same, but the scale, it's just almost unimaginable. We've gone from handwritten ledgers to data mining on a global industrial scale. So, why do we care? Well, because the prize is absolutely staggering. McKinsey estimates that the potential value from data and analytics is as high as $17.7 trillion. That's the treasure that basically every modern company is hunting for right now. So, how are the big winners pulling this off? Well, a lot of them use what's called the data flywheel. It's brilliant, actually. They offer a great product that pulls in users. Those users then generate even more data, which makes the product even better, which, you guessed it, attracts even more users. It's this awesome, self reinforcing cycle that creates a massive competitive advantage. And according to McKinsey's research, today's winners are typically running one of three plays from the same playbook. First, they become the absolute industry standard. Second, they tap into unique data that only their users can give them. Or third, they cleverly turn their own internal tools and knowledge into a product they can sell. So, for almost 200 years, this has been a completely human-driven story. But now, everything's about to change. Big time. Let's get into the next chapter and meet the AI data agent, a totally revolutionary concept coming out of IBM research. And this right here, this is the question from IBM that just flips the whole script. It's a huge shift in thinking. The goal isn't just to use AI to help humans run that three-part playbook a little better. No, it's to see if AI can run the entire playbook all on its own, from designing the system to delivering the final product. And to really appreciate what a big deal this is, just look at how it works now. Creating a new data product today is like this slow, super complicated relay race. You've got a steward, an engineer, a security officer, a data scientist, all kind of working in their own bubbles, trying to coordinate manually. A simple request can get stuck in handoffs and meetings for ages. The new model is called agentic data ops. So forget that relay race. Instead, think of a specialized elite team of AI agents. You ask for a financial forecast, and a discovery agent instantly finds the right data. A curation agent cleans it up, and a modeling agent builds the predictive model. They aren't waiting around for emails. They're like a digital dream team, constantly talking and adapting in real time to get the job done. And the crucial difference here is just one thing: speed. The old way, the human way, with all its friction, it can take weeks, or if you're lucky, days to get a finished data product. The new way, the agentic way, brings that time down to a few hours. This isn't just a small improvement, it's a total game changer. Okay, I know what you're probably thinking. This all sounds incredibly futuristic, right? Like something out of a movie. But here's the key. The blueprints for building this AI workforce are not science fiction. The foundational tools are here, today. So, the first piece of this puzzle is something called serverless architecture. To put it simply, it means these AI agents can build and run their own applications without needing a human to go provision and manage a bunch of servers. The cloud just handles all that in the background, creating this super flexible foundation where the AI can spin up whatever resources it needs whenever it needs them.
And the second piece is AI orchestration. Okay, so if serverless is the foundation, then orchestration is the brain of the whole operation. It's the system that's directing all the different AI agents and tools, making sure they're all working together to hit that final goal. It's basically the project manager for the AI workforce.
And we already have the tools designed to do this. For really predictable step by step stuff, you've got things like AWS step functions. Think of it like a factory assembly line. But for the more complex, dynamic goals, you have AI native tools like Amazon Bedrock agents, which act more like a creative project manager that can think on its feet and adapt to new information.
All right, let's bring all this home. When you put all these pieces together, you start to see we're not just talking about a faster way to build a data product. We're talking about a fundamental shift in the very nature of business itself.
I mean, just think about the incredible journey we've been on. We've gone from one person collecting credit info in a ledger to the very real concept of an autonomous system that can spot a market need, build its own infrastructure, find the data, and deliver a finished product all by itself. It's wild.
So, what does this all actually mean for you? Well, for businesses, it means being able to innovate at a speed we've just never seen before. For all of us knowledge workers, our roles are going to shift from doing all the technical work to guiding the AIs that are doing the work. And for AI itself, this is a huge leap. It can now build its own tools to solve even bigger problems down the road. And that leaves us with one last, really fascinating question. We started this whole journey talking about data, but if an AI can completely automate the creation of one type of business, what's to stop it from building any kind of business? That's the thought I want to leave you with today. What comes next?
trade's moving faster than ever. The merchants have this massive paralyzing problem.
They don't know who to trust.
Exactly. You lend money to some guy out in Ohio, you have no idea if he's a tycoon or, total fraud. And then this guy, Lewis Tappan, comes along.
Ah, the grandfather of business intelligence.
Right. He creates
Create an industry standard.
the Tappan and Bradstreet play. You become the default metric, the credit score, the Nielsen rating, that kind of thing.
Right, and this relies so heavily on the network. Once you are the standard, everyone builds their systems around you, and you become incredibly hard to manipulate.
But that's also the hardest path, I'd imagine.
Oh, absolutely. You need a massive head start or like data that nobody else can possibly access.
So if you're not the big incumbent, what's option 2?
You harness insights from an engaged user base. This is the flywheel effect we hear so much about. You use data from your core product to generate insights that make that core product stickier.
Ah, like how Spotify uses my listening history. They don't just play music, they sell me on the Discovery Weekly feature, which is what keeps me subscribed. The data product is the recommendation engine itself.
Precisely. But the third strategy is the one I find most fascinating, especially for established companies. It's turning organizational know-how into a product.
This is the sleeper hit, right? The report mentioned a European building materials company, not a software company at all.
Not at all. They just happen to have a really good internal tool for tracking efficiency on their construction sites.
And they realized all their clients had the exact same problem.
Exactly. So they polished up their internal tool, put a nice UI on it, and sold it. It turned into a $500 million business.
That's the dream. Monetize your own homework. This all brings us to the value chain, though. McKinsey talks about the DIKW framework: data, information, knowledge, wisdom.
Right, and it's usually explained with some boring analogy, but here it's really all about profit margins.
How so?
Well, think about high-frequency trading. Data is the raw ticker price. That's a commodity. Everyone has it. Information is knowing the price trend over the last hour. Knowledge is understanding why it's trending. Maybe some news just broke, but wisdom.
Wisdom is the system that automatically executes the trade to hedge your risk before the human trader has even finished their coffee.
And that is where the margin is. If you sell the raw data, you're competing on price. If you sell the execution, the wisdom, you own the outcome. That's a high margin business.
But there's a problem. You can't deliver that kind of wisdom at scale if you're relying on humans to manage the data pipelines.
Because humans are slow. And this is the perfect pivot to the IBM research paper on agentic data ops. They describe the current state of enterprise data as, well, a nightmare of silos.
A monumental task, I think was their phrase.
It is. Right now you have data stewards, data engineers, SREs, CISOs. If a business analyst wants a new forecast model, they file a ticket. An engineer builds a pipeline. The CISO has to review it. It can take weeks.
It's pure bureaucracy. And IBM's whole argument is we need to stop just automating individual tasks and start automating the management itself. This is that automation versus autonomy distinction.
It's such a crucial distinction. Automation is like a train on a track. It gets from A to B very efficiently, but if a tree falls on the track, it just stops. It's rigid.
And autonomy.
Autonomy is an off-road vehicle. It has a destination, but it figures out the path as it goes. It can navigate around obstacles.
The paper uses a great example of creating a financial forecasting product. The old way is a 6-week project with 5 different departments. Walk us through the agentic version.
Okay, so in the agentic world, a user just asks a natural language question. A discovery agent parses that request and starts hunting for the right data sets across the entire enterprise. It figures out the data is raw, so it signals a storage agent.
And the storage agent does what?
It provisions a new database instance.
Whoa, hold on. The agent is provisioning infrastructure.
Yes.
That sounds risky. I mean, From a cost and security perspective, you have software just spinning up databases on the company credit card. How do you stop a runaway robot from spinning up 1,000 instances and bankrupting you?
That is the immediate fear, and it's a valid one, but the alternative is the bottleneck we have right now. The vision here is AI for AI. The agents don't just use the stack, they build it.
Okay.
But to your point about cost and control, this is exactly why the underlying it's heavy, it smells kind of gross, and honestly, unless you have a refinery in your backyard, it's basically just a fire hazard. Companies fail. McKinsey points out that most organizations today are awash in data. They have petabytes of the stuff, but they aren't pulling a tap in. Why is that gap so hard to cross today?
I think it comes down to the difference between a project and a product. Most companies treat data as a project. Oh, the CEO needs a dashboard for Q3 sales. They build it, the CEO looks at it once, and then the data goes back to sleep. A data product has to be reusable, high quality, and crucially, it has to solve a problem for someone outside the room where the data lives.
They highlighted Walmart as a prime example of getting this right. Now, Walmart knows everything about what we buy,
Everything.
but they realized that data wasn't just useful for restocking shelves.
Right. Think about their suppliers, the people making the soap and the cereal. They were flying blind. They didn't know if their new flavor was selling in Ohio but failing in Florida.
So Walmart built Walmart Luminate. They cleaned up their internal inventory and shopper data and sold it back to the suppliers.
And it grew 80% quarter over quarter.
That is a massive pivot. You go from I'm a retailer to I'm a data broker for the CPG industry.
Exactly. And McKinsey outlines 3 specific strategies to do this. Number 1 is creating an industry standard. This is the, high risk, high reward play.
This is what we're seeing right now with the AI wars. Look at Reddit. For years, Reddit was just a place for people to argue about pizza toppings or whatever.
Or video games, yeah.
But suddenly, that argument data became the gold standard for training large language models on how humans actually speak.
And they licensed that to Google for $60 million because they became the standard. If you want human conversation, you go to Reddit. That's a tap-in level move.
Strategy 2 is harnessing insights using behavioral data to help advertisers, which is pretty standard. But strategy 3 is the one I think applies to most of our listeners. They call it organizational know-how.
This is the sleeper hit. It's when you build a tool to fix your own headache and then realize everyone else has the same headache.
Okay.
There was a European building materials company in the report, not exactly a Silicon Valley darling, but they built a tool to track their own logistics and KPIs because the off-the-shelf stuff just wasn't good enough.
And it worked so well for them that they realized the tool was more valuable than the cement.
In a way, yes. They wrapped it up, sold it as a SaaS platform to the rest of the industry. They eventually sold that spin-off for $500 million in enterprise value.
That is the dream, right? But McKinsey throws a bucket of cold water on this. They say building a scalable data business like that typically takes 3 to 5 years.
Yeah, because data is messy. Governance is hard. Sales cycles are long. You can't just flip a switch.
But we don't want to wait 5 years. This is the AI era. We want to type, build me a logistics platform into a prompt and have it done by lunch.
And that brings us crashing into the production reliability gap.
This leads us to the app.build paper. This was a technical deep dive into what happens when you actually ask AI to write software. And the headline is, those Twitter demos where an AI writes a generic game in 30 seconds.
Yeah, that is not how the real world works.
Not at all.
It's what they call the template problem. The researchers found that large language models are very good at what we call happy paths.
Okay.
If you ask for a standard landing page, it gives you a standard landing page.
Sure.
But if you ask for a complex functional application, the AI often generates code that looks correct but doesn't actually work.
They mentioned the code often passes the health check the server turns on, but when you open the browser, you get a 404 not found or a generic under construction banner.
Exactly. The AI didn't build the feature, it built the facade of the feature. It's hallucinating competence.
Right.
So if we want these autonomous agents to actually build our data business, we can't just trust them. We need a system. The paper proposes environment scaffolding.
I loved this analogy. It's like a construction site. You don't just tell a rookie carpenter, build a house and walk away for a month.
No, you have a foreman.
Yeah.
You have inspectors. You have a feedback loop.
A constant loop.
The technical term is generate, validate, repair. The AI writes a function. Immediately, the system runs a linter to check for syntax errors, and then a unit test to check logic. If it fails, the error message doesn't just go into a log, it goes back into the AI.
So the AI gets to read its own report card.
And correct itself. Oh, I missed a semicolon, or I imported the wrong library. When they wrap the AI in this scaffolding loop, the success rates just skyrocketed.
Wow.
But here's the really interesting economic finding. They compared a cheap, open source model, Qwen 3, against the top tier, expensive model, Claude Sonnet.
And you'd assume the expensive model wins. If I'm building a business, I want the smartest brain.
Right? In a single shot, yes. But inside this repair loop, the cheap model could iterate so many times for such a low cost that it actually became the better economic choice.
Yeah.
We're talking 8.2 times cheaper per viable application.
That changes the math completely. If I can run a swarm of junior coding agents for pennies and they can self-correct until they get it right, I don't need the genius model to get it right on the first try.
Exactly. It's quantity of thought over quality of first draft. Quantity of iteration has a quality all its own. But there was one counterintuitive finding in that paper regarding testing that really surprised me.
This part confused me at first. I mean, in software engineering, more testing is always better, right? Test everything. But they found that removing end-to-end browser tests actually improved the success rate.
I know.
Why would deleting tests make the software better?
It comes down to brittleness. An end-to-end test involves a bot opening a browser, clicking a specific button at a specific coordinate, and expecting a specific result.
Like, click the blue button at pixel 500,500.
Right. But AI generation is probabilistic. It changes slightly every time. Maybe the AI decides to make the button green or move it 10 pixels to the left because it thinks that looks better.
A human user wouldn't care. The button is still there.
But the automated test fails. It's rigid. So the test was failing perfectly good software just because it didn't match the template.
Ah, I see. It's like firing a chef because the parsley wasn't exactly at 12 o'clock on the plate, even though the steak was perfect.
Exactly. The lesson is that when you're validating AI work, you need human-like validation checking for intent, not rigid rule checking.
Okay, so let's pause and stack this up. We have a strategy, turn data into a product like Tappan did. We have a builder, a swarm of cheap AI agents in a repair loop, so they write working code. Now, where do these agents live? Because they can't run on my laptop.
This gets us into the infrastructure layer, and specifically the AWS guidance on serverless and event-driven architecture, or EEA.
You mentioned earlier that EA gives the AI senses. Can you unpack that?
Okay, so think about a traditional script. It runs on a timer. Every hour, check the database. Every hour, send an email. It's robotic. It's dumb.
It's not reactive.
Not at all. But a human employee is. If a customer yells, you listen. If a fire alarm goes off, you run. Event-driven architecture mirrors that. The event is the trigger.
So an event could be anything. A file lands in an S3 bucket, a user clicks refund.
A temperature sensor in a warehouse spikes. In an EDA model, the AI agent is effectively asleep, costing you $0 until that event hits.
That's the serverless appeal, no paying for idle time.
Exactly. It scales to zero. But the more important part is the orchestration. Once the agent wakes up, what controls it? AWS draws a fascinating line between two approaches, rule-based versus AI native.
This is step functions versus bedrock agents.
Correct. AWS Step Functions is a state machine. It's a flowchart. If A, then B. If B fails, do C. It's deterministic. You use this when you need absolute certainty.
Like moving money.
Exactly. If I'm transferring $10,000, I do not want the AI to get creative.
You
I
know.
want it to follow the flowchart exactly. But what if a user says, I want to return these running shoes because they hurt my ankles?
A flowchart struggles with that. Too many variables. Are the shoes worn? How long has it been?
That is where the Amazon Bedrock agent comes in. You don't give it a flowchart, you give it a goal and access to tools. The agent figures out the path that thinks, okay, intent is return, first, verify the order, second, check the return policy, third, generate a label.
The human defines the what, the AI figures out the how, but this is where I get nervous. We've all seen AI hallucinate. If I have an autonomous agent talking to my customers, how do I stop it from promising them a full refund and a free pony?
You have to ground it. That is where RAG retrieval augmented generation becomes non-negotiable for enterprise.
RAG is a term that gets thrown around a lot.
It's simple. Imagine taking a test. A standard LLM is taking the test from memory. It might remember facts, or it might make them up.
Right.
Argity is an open book test. But it's not just any book, it's your book. Before the agent answers the customer, it has to look up the company policy document
Okay, so it retrieves the specific paragraph on return policy.
and sends that to the model and says, answer the customer using only this information. It cites its sources. If the policy isn't there, it says, I don't know. That constraint is what builds trust.
There was one other piece of the AWS puzzle I found really practical, the edge. We usually think of AI as living in these massive data centers.
But data doesn't just happen in data centers. It happens in factories, on oil rigs, in hospitals. The AWS guidance talks about IoT green grass.
Let's use the factory example.
If you have a high-speed assembly line and you're using a camera to spot defective parts, you cannot afford to send that video frame to the cloud, wait for processing, and send a signal back.
By the time the signal returns, the part is in a box on a truck.
Latency is the enemy. So you push the AI model, the agent, down to the device itself. The camera does the thinking. It decides defect or no defect in milliseconds.
That's a whole different way of thinking about where your business lives.
It is. The data business isn't just a cloud strategy. It's everywhere the data is born.
So we've covered the history, the coding, the infrastructure. Now I want to look forward. The IBM research paper on agentic data ops feels like the sci-fi chapter of this story.
It's the holy grail chapter. We are moving from automation to autonomy.
Okay, distinguish those for me, because to me they sound like synonyms.
Automation is a script. Copy file A to folder B at midnight. It does exactly what it's told, no more, no less.
All right.
Autonomy is a mission. Optimize my storage costs, or forecast next quarter's revenue. The agent decides the steps, it decides when to run, how to run, and what to do if things go wrong.
IBM uses this financial product scenario that really illustrates this. Walk us through that.
Okay, so imagine a user asks a simple question. Create a forecast for agent mutual funds. Ensure it's GDPR compliant and uses high-quality data.
In the current world, that's a project. That's weeks of meetings.
And so many email chains. In the agentic world, a system agent receives the request. It acts like a general contractor. It spins up a discovery agent to find the data, a governance agent to check the legal stuff, and a storage agent to set up the database.
They're all negotiating with each other.
And collaborating. But the breakthrough in the IBM paper is the feedback loop. Let's say the discovery agent brings back data, but the model performance is terrible.
The system detects this. It doesn't crash.
It thinks. It realizes this data is garbage. It says, I need to find a new source, or I need to clean this data set. It iterates on its own without a human logging a ticket. It's self-healing.
That is incredible, but it also triggers that Terminator reflex in the back of my brain. If the AI is writing the code, and the AI is managing the data, and the AI is optimizing the business, what are we doing?
That is the question of the decade. And the IBM paper acknowledges the difficulty of AI monitoring AI. How do you audit a system that's making thousands of micro decisions a minute?
We shift from being the operators to what?
We become architects and governors. We define the mission. We define the guardrails, the RA limits, the budget caps, the compliance rules. And then we audit the output.
So we aren't rowing the boat anymore. We're the captain on the deck holding the map.
And making sure the crew doesn't mutiny. Or, more realistically, making sure it doesn't accidentally violate a privacy law while trying to optimize a query.
It's a fundamental shift in what work looks like.
I think Lewis Kaplan would be confused by the technology. If you
Hmm.
showed him an AWS server farm, he'd probably faint. But I think he'd recognize the mission. He was sitting there with handwritten ledgers trying to turn noise into a signal he could sell. We are doing the exact same thing, but instead of quills and ink, we have swarms of serverless agents and self-repairing code.
The scale has changed, but the game remains the same. Turn the sludge into fuel.
Precisely. The barrier to entry to build a data business has never been lower, but the barrier to trust, to ensure these agents are doing what they say they are, has never been higher.
That is the takeaway. So here's my challenge to you listening. Look at that oil you have sitting in your servers. Don't just look at it as a storage bill. Look at it as a potential product. The tools to build it are cheaper and smarter than ever. But maybe keep a human in the loop for the final check.
Always keep a human in the loop.
Thanks for diving deep with us. We'll catch you on the next one.
You know, what if a business could just build itself? It sounds like something straight out of just figuring out how to sell information. That simple idea grew into the huge, complex data operations we see today. But the next leap, wow, it's into a future where AI agents are calling the shots. You know, it all kicked off with a really basic problem, trust. As merchants started expanding back in the 19th century, they had no way of knowing if someone on the other side of the country was a good credit risk. Entrepreneurs like this guy, Lewis Tappan, saw that gap and created the first data businesses to collect, analyze, and sell creditworthiness. They were literally selling trust. And that idea grew into giants we know today, like Dun and Bradstreet. All right, let's fast forward to right now. The core idea is still the same, but the scale, it's just almost unimaginable. We've gone from handwritten ledgers to data mining on a global industrial scale. So why do we care? Well, because the prize is absolutely staggering. McKinsey estimates that the potential value from data and analytics is as high as $17.7 trillion. That's the treasure that basically every modern company is hunting for right now. So how are the big winners pulling this off? Well, a lot of them use what's called the data flywheel. It's brilliant, actually. They offer a great product that pulls in users. Those users then generate even more data, which makes the product even better, which, you guessed it, attracts even more users. It's this awesome, self-reinforcing cycle that creates a massive competitive advantage. And according to McKinsey's research, today's winners are typically running one of three plays from the same playbook. First, they become the absolute industry standard. Second, they tap into unique data that only their users can give them. Or third, they cleverly turn their own internal tools and knowledge into a product they can sell. So, for almost 200 years, this has been a completely human-driven story. But now, everything's about to change. Big time. Let's get into the next chapter and meet the AI data agent, a totally revolutionary concept coming out of IBM research. And this right here, this is the question from IBM that just flips the whole script. It's a huge shift in thinking. The goal isn't just to use AI to help humans run that three-part playbook a little better. No, it's to see if AI can run the entire playbook all on its own, from designing the system to delivering the final product. And to really appreciate what a big deal this is, just look at how it works now. Creating a new data product today is like this slow, super complicated relay race. You've got a steward, an engineer, a security officer, a data scientist, all kind of working in their own bubbles, trying to coordinate manually. A simple request can get stuck in handoffs and meetings for ages. The new model is called agentic data ops. So forget that relay race. Instead, think of a specialized elite team of AI agents. You ask for a financial forecast, and a discovery agent instantly finds the right data. A curation agent cleans it up, and a modeling agent builds the predictive model. They aren't waiting around for emails. They're like a digital dream team, constantly talking and adapting in real time to get the job done. And the crucial difference here is just one thing: speed. The old way, the human way, with all its friction, it can take weeks, or if you're lucky, days to get a finished data product. The new way, the agentic way, brings that time down to a few hours. This isn't just a small improvement, it's a total game changer. Okay, I know what you're probably thinking. This all sounds incredibly futuristic, right? Like something out of a movie. But here's the key. The blueprints for building this AI workforce are not science fiction. The foundational tools are here, today. So, the first piece of this puzzle is something called serverless architecture. To put it simply, it means these AI agents can build and run their own applications without needing a human to go provision and manage a bunch of servers. The cloud just handles all that in the background, creating this super flexible foundation where the AI can spin up whatever resources it needs whenever it needs them. And the second piece is AI orchestration. Okay, so if serverless is the foundation, then orchestration is the brain of the whole operation. It's the system that's directing all the different AI agents and tools, making sure they're all working together to hit that final goal. It's basically the project manager for the AI workforce. And we already have the tools designed to do this. For really predictable step-by-step stuff, you've got things like AWS step functions. Think of it like a factory assembly line. But for the more complex, dynamic goals, you have AI native tools like Amazon Bedrock agents, which act more like a creative project manager that can think on its feet and adapt to new information. All right, let's bring all this home. When you put all these pieces together, you start to see we're not just talking about a faster way to build a data product. We're talking about a fundamental shift in the very nature of business itself. I mean, just think about the incredible journey we've been on. We've gone from one person collecting credit info in a ledger to the very real concept of an autonomous system that can spot a market need, build its own infrastructure, find the data, and deliver a finished product, all by itself. It's wild. So, what does this all actually mean for you? Well, for businesses, it means being able to innovate at a speed we've just never seen before. For all of us knowledge workers, our roles are going to shift from doing all the technical work to guiding the AIs that are doing the work. And for AI itself, this is a huge leap. It can now build its own tools to solve even bigger problems down the road. And that leaves us with one last, really fascinating question. We started this whole journey talking about data, but if an AI can completely automate the creation of one type of business, what's to stop it from building any kind of business? That's the thought I want to leave you with today. What comes next?
You walk in, my whole table leans your way. Lipstick on, same color from yesterday.
All right, let's talk about it. Okay, so what we're doing here, what we're building, is going to be, excuse me. I think I decided I'm going to talk because this is too important to not talk about it. You know? Alright, so we have to, I'm going to show my camera because I'm going to decrease the audio because you guys have to, this is very important. Some important knowledge here that I think is gonna be good for the industry. So let me put my camera up. Can you see my face? Are you able to see my face? No. All right. So basically, what we're trying to do is we're trying to see if we can have the AI talking to itself. So right now we have agents, task, live feed, and then they can respond to the task. So what it, so this is not a web app. This is a WPF application. We cannot connect to the get agents. So let's close this. Let's allow. And okay, so we need to see something important here. What we're gonna ask the, okay. We're going to check the slides to see, okay, so we have the AI factory. Let's so basically what happens is that I do not see any camera action. Does not read it. It's okay. Well, currently it is too big, so some content overflows. We need to avoid content overflowing, and smallest text should be a little bigger. Okay. Meanwhile, we're gonna present, we're gonna say data pipeline. So let's actually go on the Gemini side to kind of learn about this a little bit more. So we're gonna do a Claude. What is a data pipeline? All right, let's ideate with Claude while our thing is loading. We're going to, you should not look for past conversations because, okay, so it kind of, let's talk in, we can say, let's talk in broad terms because I want to have a new thread. Okay, so we're kind of learning about this to see. All right. What is the new protocol? Describe in a few words. Okay. So now let's see what he has done on this side. We're gonna allow it to do what it needs to do. In the meantime, we have seen that the swarm actually can receive messages. So I'm gonna send a message to the swarm. I'm going to address it to all. Okay. So this is online and ready. New endpoints available. Let's see if the app is actually running. Okay, so it says that I can run it with status, task, send, say hello, feed, status, and what if we're in development mode? We just want to inject it into a CLI session and have the, okay. So that's the idea of, okay. So data pipeline is the nervous system, okay? Nervous system of an AI-powered business. So before that, before what we called AI was AI, you have to structure the data in a reliable way. And what is important too is ingestion. So that's what we're doing right now. We're trying to ingest data because we have to capture the raw signals first, right? We have to capture the raw signal, and then we normalize it. We give it some shape, and then we persist it. So to test our theory, let's see if we can go into our system, okay? Let's go here. Okay, this is building. Let's go and ask it to send a message to all, okay? I'm going to say to our orchestrator, let's ask our orchestrator to do something for us. I don't know if the screen is too dark. Let's make it a little nicer to read, especially on small screens. Okay, I think this one is a little better. Okay, so it has given us the comment. It's running it. So we're going to check now if, oh, it figured that there was a routing error. And after 3 attempts, it says cannot connect. So let's check that on that side. Okay, this is building, okay? Let's check on our feed to see. So 3, can I open our console? This is everything that it did, okay? So that's the in light. I'm gonna put that in the chat. So that's what, right? So now in C#, what would be, without writing any code, what would be like the functions? The first function, we're trying to go from little by little. It's going to, okay, so we have to ingest it. So it's the front door. So we accept something that's coming in, we step with metadata, where it came from, and we pass it forward. We don't validate, we don't transform, no store, just receives and steps. So we are going to actually go into, we're going to check if, okay, we're testing right now. So the system is not yet ready to test. So we're going to check. Okay, so now let's check our termic to see if we can receive data from the server. So okay, so it should run soon. Build, failure to build. Save that in there. Paste. Okay. Now let's see if our server is responding again. Okay, so we have the new endpoints. So start. Let's copy this. We're gonna spin off. Okay, so we're going to tell it to read this protocol. Okay, so now this is running. And hi, online and ready. Okay, so let's put this side by side. So this is our chat protocol that we've invented. This is a okay, so I have created this, and now I can assign tasks to different agents and they can work independently. So now agents can work independently and much easier, much better. So now what do we need to do now? Okay, so now we're going to check. I'm going to send a message to Termic. I'm going to say at Termic, at multi-Termic dev, show me your, okay, I'm gonna say, tell me about your architecture. Let's see if it can receive this message and if it's going to work on it. Okay, it has not received the message. It's frozen, that's why. So we're gonna close this, online and ready. Okay, so once I click close here, if I click close, this should say offline. Ready? Let's try that. I'm going to click close. This should have said offline. Well, let's refresh to see if that says offline. Okay, it says busy, so that's a bug. It should say disconnected. Okay, let's go and say, let's tell our server. Okay, now we need a better way to track when agents are connected or not. Right now it shows busy, but I think we have to differentiate between online and busy. Okay, meanwhile, let's check we're gonna play our okay, so this is, remember on our Chrome, we had this we had this simple analysis, right? That basically said, let's go to our analysis, and that shows us that the data pipeline, right, is the nervous system. So we have to be very, very careful to not, because, okay, let's actually ask Claude, can you show me kind of that as an illustration, the data pipeline? Okay, it's going to give us an illustration of what we're trying to understand here, the pipeline of the data. Meanwhile, let's check our slides. Let me check this. Okay, so it's building its thing. We're not gonna check the chat protocol yet. Okay, there's another issue. Okay, I'm going to basically try something in here. run and monitor here. Let's see. Okay, so what is important is that we need to add some padding to our controls because we cannot see some of the controls. Okay, let's open our data pipeline. Let's see the illustration. We're going to check our illustration. It's a dark mode. They love dark mode for some reason. We need light mode and kind of dark text. Light mode. Okay. But what it's trying to do here, it's trying to display the pipeline that we're building. The first thing is the ingesting. You have to ingest the data. It's like anything, like receive it. So we already have that set up, the receive event, to show you that this is working. We haven't even done the normalize. You haven't done parsing yet, and store it. So a lot of time we skip straight to AI inference, but without the plumbing, we're gonna be stuck with chatbots forever. We don't want to be stuck with chatbots forever. We want to have a richer interface. Okay, so now let's I think we're gonna say two.
I want to start by taking you to New York City, but not the version we know. We're going back to 1841.
Okay.
It's gritty, it's loud, and there's a merchant named Louis Tappan who is staring at a massive problem.
Right.
He wants to sell goods on credit, but he has absolutely no idea who is actually good for the money and who is, going to vanish.
It's the eternal problem of commerce, right?
Yeah.
Trust. If you don't have trust, you don't have a market.
Exactly. But Tappan doesn't just complain about it. He builds a network. He gets correspondents all over the country to send him updates on local businesses.
Wow.
He compiles these massive ledgers recording creditworthiness. A few years later, John M. Bradstreet does the same thing.
Right.
Now, here's the kick. They weren't building software. They weren't training neural networks.
Not even close.
But McKinsey, and this is in one of the papers we're looking at today, argues they were effectively the first data businesses.
That's a fair assessment. They realized that the information about the transaction was actually more valuable and harder to get than the transaction itself. That lineage leads straight to Dun & Bradstreet today.
And the reason I'm obsessed with this story today, Sunday, February 1st, 2026, is because this stack of research we have suggests we have finally closed the loop on what Tappan started. We aren't just collecting data anymore. We aren't even just analyzing it manually. We are entering the era of agentic data ops
Yeah.
and autonomous software factories.
It is a massive shift. We've gone from, passive ledgers that sit on a shelf to active agents that write code, manage infrastructure, and make decisions.
It's huge.
And we have a stack here ranging from that strategic McKinsey guide on data profitability to some very, very dense technical papers from Databricks and IBM on how AI is actually architecting its own environment.
Plus, we have a very specific, slightly weird nostalgia trip involving a pirate cat named Captain Claw,
I was hoping you'd get to that.
which I promise connects to the future of open source.
I am very ready to discuss the pirate cat.
But let's start with the money. Before we get to the robots building robots, we have to look at the business model. McKinsey published this report back in July 2024, noting that 40% of business leaders expected to build data or AI businesses.
Right.
Now that we are in 2026, we can see that a lot of those people failed. And they failed because they didn't understand the difference between data and wisdom.
Right. They use the DIKW hierarchy: data, information, knowledge, wisdom. It sounds a bit academic, but it's actually a roadmap for margins.
Okay, play devil's advocate here. Isn't wisdom just a fancy consulting buzzword for analytics?
Yeah.
I mean, every company claims they sell insights.
Sure.
Why does McKinsey think this distinction matters so much?
It's not just a buzzword, it's about unit economics.
Yeah.
Data is raw. It's facts, logs, demographic lists.
Right.
The problem is, in the age of AI, data is commoditized. It is incredibly cheap to scrape, buy, or generate.
So your business is in trouble.
If your business model is, I sell a list of homeowners, you are in a race to the bottom. Your margins are going to zero.
Because anyone can get that list.
Exactly. But wisdom, or actionable insight, is at the top of the pyramid. That's where you answer the what question.
Okay.
Wisdom isn't telling a client, it rained yesterday. It's telling them, because it rained yesterday, and because we know your supply chain latency is 48 hours, you need to reroute these 3 trucks right now to avoid a stockout.
Ah, so that's something you can charge for.
That is worth paying for.
That distinction makes sense. It's the difference between a weather report and a logistics strategy.
Precisely. And the report highlights a European building materials company that just nailed this. They had a boring internal tool, just a KPI tracker for their own efficiency.
Okay.
But they realized that the logic inside that tool, the organizational know-how, was the valuable part. They packaged that logic and sold it as a product.
And that pivot turned an internal spreadsheet, effectively, into a $500 million business.
Right. And that's the lesson. You don't sell the raw materials. You sell the process of turning those materials into a decision.
Okay, so step 1 is realizing your wisdom is the product. But step 2 is where the tech gets heavy.
Right.
Let's say I have this great idea for a wisdom product. Historically, I need to hire a team of developers, spend 6 months building an MVP, deal with bugs, delays.
The usual nightmare, the reliability gap.
Right. And we have a paper here from Databricks and the Technical University of Applied Sciences, Würzburg-Schweinfurt.
Let's just call them THWS.
Yeah, THWS, about a framework called app.build. They tackle the elephant in the room. LLMs are great at chatting, but they have historically been terrible at writing complex production-ready software in one go.
It's the one-shot problem. If you ask a 2024-era AI to build me a snake game, it writes one long script. There's a bug, or if it hallucinates a library that doesn't exist,
The whole thing just fails.
it fails. It doesn't know how to iterate.
So how does app.build fix that? Because the paper claims they generated over 3,000 working apps in 4 months.
Which is insane volume.
It's an insane volume.
They do it by wrapping the AI in what they call environment scaffolding. It's a rigorous, multi-step process. It starts with structured decomposition.
Which means breaking the problem down before writing a single line of code.
Exactly. The system takes a prompt and forces the model to specify the file structure, the dependencies, the requirements first.
Okay.
It breaks the snake game into the game loop, the rendering logic.
Which
the
one can I
handler.
inject into the terminal?
Then and only then does it move to the generate phase.
You kinda
Okay, but models
infer what's
generate
going
bad
on.
code all the time. What happens
That's what
when the
I want.
code breaks?
That's the
It's
validate
kinda
and
like
repair loop.
You
This is the
start the
magic
process,
sauce.
This is the
and then
key.
you observe
The
it.
system takes the generated code and actually tries to compile or run it in a sandbox. If it throws an error, say a syntax error or a failed unit test, the scaffolding captures that specific error message.
And feeds it back to the model.
Yes, it effectively says, you tried to use pygame.init, but you didn't import pgame. Fix it. and the model repairs it.
So it's a feedback loop.
It creates a feedback loop that mimics a human developer Googling an error message.
That makes perfect sense. But I want to drill into the economics of this because there was a stat in this paper that stopped me in my tracks. They compared the cost of building apps using a top-tier expensive model versus a cheaper open weights model wrapped in this scaffolding.
The numbers are wild. They compared Claude Sonnet 3.5, top of the line, against Qwen 2.5, which is an open model you can run pretty cheaply.
And the smart model Claude cost about $5.01 to generate a viable app.
Right. But Qwen, the dumber model, when wrapped in the scaffolding loop, produced viable apps for 61 cents.
61 cents.
61 cents. That's an 8.2x cost reduction.
This completely upends how we think about intelligence in AI.
Yeah.
We've been obsessed with building bigger, smarter brains, GPT-5, GPT-6.
Right.
But this suggests that a mediocre brain in a really good process.
It's the process over IQ argument.
Yeah.
If you have a good gym, a good environment that catches errors and forces corrections, you don't need the Einstein of AI models. You can use the intern, provided the intern has a rigorous checklist.
And if software costs 61 cents to build, that brings us to a terrifying question. What happens to the software industry? If I can spin up a custom CRM for my specific niche for less than $1, why am I paying Salesforce $50 a month?
That is the disposable software theory. We might be moving toward a world where software isn't a durable asset you buy and maintain, it's a disposable wrapper. You generate an app for a project, use it for a week, and then you delete it.
But if the software is disposable and the code is cheap, then the only thing of value left is the data.
Exactly. We are right back to tap-in. The app is just the container. The wisdom, the data flowing through it is the asset.
Okay, so we have the strategy and we have the cheap builders. But now we have a management problem. You can't just have 3,000 apps running wild with no supervision. You need someone or something to manage the data.
This is where the IBM research paper on agentic data ops comes in. This was published December 2025. Arguing that we need to move from automation to autonomy.
Because I feel like we use those words interchangeably.
Automation is a script. If X happens, do Y. It's rigid. Autonomy is goal-oriented. I need this data. Figure out how to get it.
So instead of a data pipeline that breaks if the file format changes.
You have an agent that looks at the file, realizes it changed, and adapts.
Okay.
Precisely. IBM proposes an agentic stack. Imagine a boardroom of bots. You have a discovery agent, a storage agent, a compliance agent.
And I imagine they don't always get along.
They absolutely shouldn't. That's the design.
Ah.
Let's say you are a financial analyst and you ask the system, get me the transaction logs for our European users for the last year.
Okay.
The discovery agent says, I found them. They are in this obscure database. It prepares to pull the data.
But then the compliance agent steps in.
Right. The compliance agent, who has digested the GDPR rulebook, says absolutely not. You cannot move that data to a U.S. server without anonymizing it first.
So they have to negotiate.
In a sense, yes. The agents have to resolve the conflict. The discovery agent might say, okay, I will apply an anonymization filter first, and the compliance agent says, approved.
This sounds great, but it also sounds dangerous.
Yeah.
What if the compliance agent hallucinates? What if it decides that, I don't know, sending credit card numbers in plain text is fine today?
That is the biggest risk. Hallucinations in creative writing are funny. Hallucinations in data governance are lawsuits.
Right.
That's why IBM emphasizes human in the loop.
But not just a human rubber stamping things.
No. The human acts as the Supreme Court. The agents do the work, they propose the architecture, they flag the conflicts. The human resolves the edge cases and sets the high-level policy.
So you're not writing SQL anymore.
You aren't writing the SQL queries anymore. You are defining the constitution for the bots.
That requires a completely different skill set. You're not a coder, you're a policymaker.
Correct. And for these agents to work for them to negotiate and react in real time, you need infrastructure that supports that.
Yeah.
You can't have agents waiting 10 minutes for a server to boot up.
Which brings us to the nervous system. We have an AWS guide here from January 2026 on serverless architectures. The keyword seems to be E-Day event-driven architecture.
E-Day is non-negotiable for agentic systems. Traditional software polls. It wakes up every minute and asks, is there new data? Is there new data?
Which is inefficient and costs money.
It's extremely wasteful. In an event-driven world, the agents sleep until something pokes them.
Right.
An upload to an S3 bucket is an event. That event triggers Amazon Event Bridge, which wakes up a Bedrock agent.
So it's reactive.
It is, and AWS draws a really interesting line in the sand between rule-based orchestration and AI-native orchestration. They contrast AWS step functions with Amazon Bedrock agents.
I've used step functions. It's basically a flowchart, right?
Yes, it's deterministic. State A always leads to state B. You use this for high-stakes, rigid processes. If you are processing a bank transfer, you want step functions. You want a perfect audit trail. You do not want an AI improvising with your money.
But if I'm trying to help a customer return a pair of shoes,
That's where Bedrock agents shine. A conversation is messy. The customer might say, I want to return these, but I lost the box. Or, can I exchange it for a blue one?
a flowchart breaks there.
It breaks. An agent can figure out the intent, oh, they want an exchange, and dynamically call the right API.
So the future stack is this hybrid. Rigid flowcharts for the math, flexible agents for the messiness.
Exactly. And all of it running on serverless Rails, so you only pay when the agents are actually working.
I want to pivot here because we've talked about the tech and the business, but we haven't talked about the feeling of building this stuff.
Okay.
And this is where I want to bring in the pirate cat.
Captain Claw.
We found a Reddit thread
I want to start by
from
taking you to
about
New York City,
9 years
but
ago,
not
2017.
the version we know.
The community was trying
We're
to
going back to
re-implement a
1841.
1997
It's
platformer
gritty,
game
it's
called
loud,
Captain Claw.
and there's
so it would
a
run on
merchant
Linux
named Lewis
And
Tappan
reading this
who
thread,
is staring at a massive
it's
problem.
painful. Right.
He wants to sell goods on credit, but he has absolutely no idea who is actually good for the money and who is, going to vanish.
It's the eternal problem of commerce, right?
Yeah.
Trust. If you don't have trust, you don't. Is a time capsule of developer misery.
It really is. I've been there. You have people screaming about SME make errors. Someone is trying to compile libsdl2 and it's clashing with their video drivers.
Wow, man.
There's a guy complaining about an infinite jump bug that he's been chasing for 3 days.
It highlights how much friction used to be involved in just getting software to run. These people weren't even working on the game mechanics half the time. They were fighting the environment.
They were fighting the compiler.
Yes.
It was a labor of love, but it was heavy on the labor. Now, fast forward to 2026. We looked at a GitHub repository for something called OpenClaw,
Right.
but it's not the game.
No.
Good
It's an
part.
open source AI assistant, 118,000 stars
Idea
on
is that,
GitHub.
Their tagline is the lobster way.
Yeah.
you
And
should
instead of
generate
files
stuff
about
that
graphics
even
drivers, the
play it,
repositories are things like ClawHub,
also
a directory of
support-
skills, and Lobster, which is a workflow shell.
The contrast is stunning. In 2017, the community was collaborating to reverse engineer binary files and fix jump bugs. In 2026, the community is collaborating to build agents that automate the coding process itself.
But here's what I love. The culture hasn't changed. You look at the Issues tab on the OpenClaw repo, and it's the exact same energy as that Reddit thread.
Really?
Hey, I found a bug in the workflow. Hey, can we add this feature?
It's the same drive. Humans love to build tools. We've just leveled up. We went from digging with spoons,
I'm going to
fixing
create a set of
compiler
two
errors
slides based on
manually,
the
to
idea that
driving excavators.
We're building the excavator.
We are
Based on
building the
slides.
lobsters that build the apps.
But a lobster doesn't care about
Following the
libsdl2. It
concept,
handles the
and we'll
dependencies
have
for you.
code examples,
Exactly.
SVG
We have
illustrations,
abstracted away
title,
the pain that the
and
Captain
then
Claw fans were
content.
feeling.
So let's pull this all together. We started with Lewis Tappan in
Tappan
1841, manually checking who was creditworthy.
Right.
We moved to the wisdom
then
economy, where the insight is the product. We saw how app.build proves we can generate software for 61 cents if we have the right scaffolding. We have IBM's agents negotiating data governance, and AWS providing the nervous system.
And we ended with the realization that the open source spirit is now focused on building the automation itself.
I want to go back to that 61 cents number,
Yeah.
because that is the thing I can't shake.
Yeah.
If the disposable software economy is real, what does that actually look like for our listeners?
It means we are approaching a world where the barrier to entry for solving a problem with software is effectively zero.
Okay.
Think about how many times you've thought, I wish I had an app that combined my calendar with my grocery list and my budget.
Right.
But you never built it because it would take weeks.
Right. I just use a messy spreadsheet instead.
In a world of 60-cent apps, you just describe that problem to an agent. It spins up the app, you use it, maybe you use it for a month, realize you need a different feature, and instead of updating the code, you just ask for a new app.
You throw the old one away.
You throw it away, the software becomes ephemeral, it's a wrapper.
That is terrifying for anyone whose identity is wrapped up in being a coder.
It is, but it's liberating for problem solvers. The skill shifts.
Right.
It's no longer about knowing the syntax of Python or C++R. It's about knowing how to design the scaffolding.
It's about being the architect of the gym.
Exactly. Can you define the constraints? Can you define the validate and repair loop? Can you set the policy for the compliance agent? That is the new engineering.
And ironically, that brings us full circle to Lewis Tappan. He didn't write code.
No.
He designed a system, a network of correspondence to extract truth from noise.
He designed the scaffolding for trust. We are just doing it with agents now.
So for everyone listening, here is your provocation for the week. I want you to look at your workflow. Look at the things you do manually, because there isn't an app for that. If you could snap your fingers and have a disposable app for 61 cents to solve that specific problem, what would it look like?
And more importantly, what rules, what scaffolding would you need to give the AI to make sure it doesn't hallucinate and destroy your data?
That's the prompt. From pirate cats to disposable software, the world is moving fast. Thanks for diving in with us.
Always a pleasure.
So what we're doing now is kind of weird. Trying to see if the agent can talk to themselves and each other, but also it's hard to live stream because this is like okay. Now let's see if a message has been received, and I can say check again how many we have connected. Okay, now we can please like and subscribe for next time because we're building something very interesting here. If you're not watching, well, you're not subscribed yet, do that next time because this is it's like industry secrets you're getting here. Things that are happening in the industry. You're getting them for free. So it's better to subscribe so you don't miss out next time because we're gonna create something very important here. We are already creating it. Okay, we have 6 agents, right? We have 6 agents. Nobody's online right now. Okay. So we're gonna make someone online. Okay. What we can do now is we're gonna play another round of our